Hi, allesammans. It is such an honor to be able to do the last speech, the last final talk of Starmus. And when Garrick asked me to do the final wrap-up, I wanted to think of a message that I could share from my space flights that was kind of a philosophical, what I learned from space. And so what I want to do is take I guess what we built on this week. We had such amazing lectures in physics and neuroscience and biology. We had great entertainment this week with concerts and the Leonov spacewalk film. My favorite was the hands-on interaction with the VR presentations. VR, the Champions, was awesome. And so we had this amazing week of Starmus, and I want to try and take some lessons that I learned, and I'll walk you through my space flight and then share a final thought with you. My most recent space flight was a 200-day mission on board the space station. And as you all know, these missions are launched in crews of 3. So they go from the Baikonur Cosmodrome in Kazakhstan. My crew on TMA-15 was myself, Anton Shkaplerov, was a Russian cosmonaut commander of the Soyuz. And then Samantha Cristoforetti was my Italian-European crewmate. When we launched from there were already 3 people in space. But the experience of launching on a Soyuz is amazing. My first flight was on the space shuttle, which is incredible, from Florida. But it's a much different experience than the Soyuz, which is an old Soviet-era nuclear rocket. It's an ICBM. And you're strapped into a very small capsule. There's a big metal container around your capsule, so you can't see out the first couple minutes. And when the rocket's light, you get kicked back in your seat really violently. It burns for a few minutes, and the first stage separates. And you get kicked forward, and you float for a few seconds. And then the second stage lights, and you get bang back in your seat. And it's a very kind of violent ride on this nuclear rocket into space. But the thing that's amazing is that you're leaving the planet. Like, there was Earth, and now you're not on Earth anymore, and you're going into space. And I can still remember on my first flight, the first time I saw Earth from space in the daylight. We launched at 4 in the morning from the Kennedy Space Center. My Soyuz flight was also at 4 in the morning. So if you ever have a chance to go into space, I highly recommend early morning flights are the best. So 4 in the morning was my favorite time. But we launched at 4 in the morning. A few minutes later, we're going over the North Atlantic into the sunrise. And sunrises in space always begin with this intense blue atmosphere. It's a thin blue line, but it's very intense. And I was busy as a pilot doing things. I looked up, and I thought, I've never seen that shade of blue before. It was the most intense, deep, kind of a royal blue. But that thought really has stuck with me ever since then. And then over the following, I've spent over 7 months in space. There's just so many different views of the Earth that you get that are scenes that you've never seen before. I've never had that view before. What I really loved on my Soyuz flight, I was flying with Samantha, who was a first-time flyer. She was a rookie. And she was the flight engineer, so she was really busy helping to fly the spaceship. And I had some duties, but I didn't have as many as she did. She was really busy. So we had been launched about 30 minutes or an hour. We were in space. She was typing and helping Anton and doing her work. And the window right above her seat, I looked over and I saw that. And I said, Samantha, look at that. And she was busy. She looked out, and I can still remember the look on her eye was so cool, for lack of a more formal term, to see like a human being for the first time seeing Earth. I really loved that experience because I had the same one myself years before. Once we got into space, there were 3 crew members who were joining us. The space station is a continuous rotation of 3 people, launching 3, return to Earth 3. So when we had gotten there were 3 folks waiting for us. We became Expedition 42. A few months later, those 3 returned, and another 3 showed up, and we became Expedition 43. So my Soyuz crew is in the blue, me, Samantha, and Anton. And the guys in red, Scott Kelly, Misha Kornienko, and Gennady Padalka were the ones that came up to meet us. Scott and Misha were there on a year in space flight, They stayed 340 days in space, and they're both just awesome guys. I love flying with them. And Gennady, while we were there, became the human with the most time in space ever. He's been in space for over 800 days. And it was amazing, right? And he wants to go back. When I retired, he was mad at me. He calls me Commander, which is, he's like the most experienced astronaut ever. Commander, I wanted to fly with you again. He wants to have 1,000 days in space. So I don't know if he'll get the 1,000 or not, but it's amazing. He's lived for years in outer space. So this is our crew. What I want to point out here is that during my training and during my flight, the Ukrainian Civil War happened. Russia annexed Crimea, and the West put sanctions on Russia, and the Dutch airliner was shot down. All of these really bad things were happening on Earth. West-Russia relations were at an all-time low since the worst time of the Cold War. And yet, here we were flying in space. The night before launch, I'm an only child. Me and Samantha and Anton were sitting there. We got some cognac out, and we said a toast to each other. And I said, look, I'm an only child, guys, but you're my brother and you're my sister. That's how close we had become. The highlight of my space flight, honestly, one of the things I enjoyed the most was every day when the work was done, I would go down the Russian segment, and we would have dinner together. So, we loved flying together. We still keep in touch. We're sending each other texts this week. We've become lifelong friends. So during a time when the conflict on Earth was really pretty significant, I think the thing I was most proud of, my crew, was that we worked together well in space. We were in this spaceship where there's a thin little bit of metal, and on the other side of that metal is instant death, right? So we had to survive together. And not only survive, we didn't just survive, but we worked together. There's a lot of stories of things that we did. I was very proud of that international cooperation of the space station. So at a time when all these things were happening on Earth, things were going well in the space program. Yes, absolutely. So I have to apologize to all the physicists in the office here. When you get into space, the first thing that you feel is this overwhelming force of weightlessness. The views of Earth are amazing, but the weightlessness, to me, felt like this force that affects everything. Unless you have a Ziploc bag or some Velcro or some duct tape or a pocket, it will float away immediately. And I mean, everything is just floating. It's something that your brain doesn't know because you just don't ever experience that on Earth. And so, again, I'm just a pilot, I'm not a physicist, but the force of weightlessness is really powerful. And the other thing is, all the physics that my brain thought it knew and had learned for all the years that I lived on Earth, changed and disappeared. This is a ball of water with an Alka-Seltzer tablet in it. So the doctors gave us a little bag of toys to play with, like a syringe. You could make water balls, and you put Alka-Seltzer in there, and little water things shoot off, and it's really cool to look at. But your brain is like, wait a minute, that's not physics changed. Something happened here. So the experience of living and learning to live in weightlessness was really interesting, because when you're a child, you have a year, 2 years, 3 years to learn how to walk and run, and you can take your time. When the gravity gets turned off and those engines shut down, and it doesn't get turned on again for 200 days, you have to learn immediately. Like you have to think, you have to learn how to move and walk and work and hold tools and eat food just immediately. You don't really have, there's no training time. It's a digital step function. Another part of living in space that's really important is exercise. Weightlessness induces something that's like osteoporosis. A lot of women get that bone disease. Your bones atrophy naturally when they're, like even right now I'm supporting my weight, my muscles and bones are working. Everybody in here's muscles and bones are working right now, even just doing nothing. And in space you don't have that at all. So NASA has prescribed a 2.5-hour workout regimen, which is kind of cool. It's kind of like going to a health spa for 6 months. I came back in pretty good shape. And in those 2.5 hours, we would do weightlifting and also cardio. So I love this picture because you can see the treadmill on the wall, which doesn't matter at all. We wear shoulder pads with some bungee cords, and I would usually run with maybe 60 kilos of force, so not my whole body weight, but more than half of my body weight pulling me down. And the treadmill is not firmly attached to the station, it floats. If it was firmly attached to the station would just rattle apart and break because of the vibration that we would induce. So it floats to alleviate or to prevent any of the vibration from going into structure. So you're running, being pulled down on this wobbly thing, and it takes some time. It's probably like watching an American trying to cross-country ski for the first time. It takes a little bit of time. But once I learned how to do it, it was great. It was really a lot of fun. In the same picture, this is a module I installed on STS-130. You can see the bathroom is right next to me. That big white cabin is our bathroom. And then behind that, on the ceiling, there's a blue and a gold plate. And that blue and gold thing is the exercise machine. And there's no weight, so there's vacuum tubes, and it's the vacuum that generates the force. And you can have 250 kilograms of force. You can really hurt yourself. It's actually, you have to be very careful on that. And you can do deadlifts like this, or deadlifts, squats like that. You can do bench press. You can do crunches for your stomach. You can do lots of different exercise. So 200 days, 2.5 hours a day of exercise. When I got back to Earth, I had lost 0.0% of my bone density. And the week I got back, I did 20 pull-ups. So I came back to Earth in really good shape. The first day I was really dizzy. I could walk around, but it was like, it was pretty dizzy. The second day wasn't too bad. The third day, it was good. But physically, I was in good shape. So the space station has shown that humans can live and work in space and come back to Earth in good shape. There's still a threat from radiation and cancer, and that's something that, it is what it is. When you're out in space, there's more radiation. But I think that's a really big achievement of the space station. The mission of the space station is science. And this is a picture of me working in what we call a glove box. It's a glass container, so you can do sort of dangerous things in there. If it breaks, you don't want it to float out. This particular thing I was working on was E. coli and salmonella. Biology gets intensified in space, so immune systems drop and aren't as powerful. The ability of organisms to interact and pathogens become worse in space. So you can do biological experiments in space that are interesting to researchers on the ground. And so I spent a whole weekend working on the salmonella and E. coli in this thing and lots of other things. Another thing, once we do these biology experiments, we put them in a freezer that's called Melfi. It's a minus 95 degrees Celsius freezer. So you can take whatever experiment you're working on, or if it's human blood or urine or whatever, and freeze it. And you don't have daily trains back to Earth, but every few months a cargo ship will go back, and these minus 95 degree samples are frozen, and the biologists and scientists on Earth can study them. So science is a big part. It's not only biology, we have physics. My favorite one is an experiment called AMS, which is looking for antimatter that's going to tell us, hopefully, what the universe is made out of, how much dark matter, how much dark energy. And on one of my spacewalks, I actually was on it for a few seconds. That was kind of cool. It was near my work area. Combustion science, basically any type of science that you have as a kid in school or in university, somebody has an experiment going on the space station. Another part about living in space is that you get to see some physics in action, like orbital mechanics. And the orbit that we're in goes from 51 degrees north to 51 degrees south. So it doesn't quite make it to Trondheim, but you can see it. You'll see it here in a few slides in the distance. But there's a thing called beta. And just like we're all enjoying right now, the sun never sets. Beta is the angle between the sun and your orbit. So if you're going in orbit like this and the sun is right overhead, your beta is 0. If the sun is over here off your left wing or your right wing, your beta is 90 degrees. And at high beta, and the space station can get up to about 75 degrees of beta, so almost off your left wing, the sun never sets, which is really cool. So this is what it looks like when you're in space. And I went through 2 periods of high beta where it's about 10 days where the sun doesn't set. This is an orbit around the Earth, looking out the left window on a time lapse. So it was fascinating to be able to see orbital mechanics. I had learned equations when I was in college, but that was pretty cool, yeah. Another aspect of life in space is spacewalking. And as a fighter pilot and as a test pilot, I had done some things, and I had flown on the space shuttle, and so I thought I had done a lot of stuff in life. And then when I did a spacewalk, I was like, this is something that I've never done before. There is nothing at all like spacewalking. It's definitely a unique thing as far as what I've done. The suit itself is like a mini spaceship. It has cooling and communication and about 10 different layers of material to keep you protected from the vacuum. It's like its own little spaceship. You can see at the bottom of my backpack, there are some small little rocket engines that uses carbon dioxide gas. If you accidentally come off the station, you can fly yourself back. But spacewalking for me was something that was absolutely unique. And the jobs that we had were, we laid cable for future capsules. America has Boeing and SpaceX that are making human capsules that'll be taking people to the space station. So we were cable guys. If you've ever seen the movie Larry the Cable Guy, that was us. And I was also a grease monkey. I had to lubricate the robotic arm. It had been outside in space for about 10 years, moving these mechanical joints around, and they were getting creaky, so I went out and put grease on them. So I was a grease monkey and a cable guy. This picture I love. In 2015, NASA tweeted it as space selfie, hashtag space selfie, and it won like selfie of the year. It was a cool picture. Except it's not a selfie. I don't know if you guys can see it, but that's me in the visor. I'm upside down taking the picture of my crewmate there. So it's like Neil Armstrong on the moon. There's no pictures of Neil on the moon. Neil was taking pictures of Buzz. So all those pictures, you could see Neil in Buzz's visor, but that was it. So this picture's funny. Some of you guys may have seen it on Twitter. But it's still a cool picture with the Earth in the background, and it's a beautiful shot. This picture I love. I took a GoPro outside and actually helped to make an IMAX movie, Beautiful Planet. So if you've ever seen Beautiful Planet, the spacewalking scene was of that. And this is just a screen capture of the GoPro. It was attached to my chest. And on the left, that white thing is the robotic arm. And basically, we took a coat hanger and bent it out and made a little tray. And I would hold it, and I'd pull the grease gun out, and I'd squirt grease into this tray, and then I'd stick it down in there without touching any of the equipment. I had to wedge it through and get it on the bolt, and then rub it on the bolt, and then pull it out. It was actually a really difficult thing to do, but it was a coat hanger, some tape, and a grease gun. This was the high-tech thing. And Samantha was driving the arm, and she was amazingly good. She was really efficient. We had 2.5 hours. And I would say, all right, I'm ready. All right, rotate it 20 degrees, pitch it down 10 degrees. And she was moving it so I could reach the things. And it took us like 2 hours and 29 minutes, and we got the whole thing done, which I was really proud of because another crew later tried the other end of the arm, and they'd only got like half of it done. So I was kind of proud of that. But the reason I like this picture is because I was there busy doing this work. It was hard. It was focused, mechanics, connector, and then I would look over here and see the most beautiful, like I'm hearing from God. I'm seeing something that humans were not meant to see. And then back to work because I got to get this thing done. And it was a juxtaposition between the mundane mechanical work, and you just can't imagine how beautiful this site is out there. Unfortunately, 99% of the spacewalk was the work. I just felt like I had to work. I didn't have time for that, but every once in a while I would get this glimpse that was like seeing creation from heaven. It was amazing. So spacewalking was amazing. So all these things I've done, spacewalking, flying space shuttles and jets and stuff. By far, the most stressful thing I've ever done is cut Samantha's hair in space. So there may be some Italians here. I know there's lots of Europeans here, and many of you have heard of Samantha Cristoforetti. She's the rock star of Italy. So if I would have messed this up, there would have been 40 million angry Italian women at me, and that's something I did not want. But this is a three-person. I actually, before launch, Samantha wouldn't let me launch until I went with her to her hairdresser and learned like how to put the clips in and that was my go for launch criteria. It's a three-person job because Anton had to hold the vacuum cleaner. So I would cut the hair, and then it would get sucked into the vacuum cleaner. But that was a big. We did that twice in space. And something to realize about space is that nothing is made there, except for electricity. We can make electricity with the solar panels. Everything else is made from Earth. So part of the flow of the space station is 3 people up, 3 people down. The other part of the life of the space station is cargo ships. So every month or two, a new cargo vehicle would show up. The Dragon, the Japanese HTV, Orbital Cygnus all come to the American segment, and they fly in formation going 25,000 kilometers an hour, and we would reach out with a robotic arm and grab it and then attach it to the space station. And these vehicles were great because they had chocolate in them, and they had underwear in them, and they had equipment that we needed and science experiments. On the Russian segment, we had the Progress and the European ATV, and they would automatically dock. There was no robotic arm. They just flew up and docked themselves. But while I was in space, there was an 8-month period around my 7-month mission where we lost an orbital Cygnus, exploded. We launched a Russian Progress that exploded, and we lost a Dragon, a SpaceX Dragon exploded. So we lost 3 vehicles in 8 months. And the space station continued, which was an amazing testament to how much forethought had gone into pre-positioning food and equipment that we needed. Even losing 3 ships back to back to back, it survived. But when the Progress blew up, it launches on the Soyuz rocket, the same one that we launch on. So they delayed our return crew to make sure the rocket was safe for the people. And while they delayed them, they delayed my return to Earth by a month. So normally it's less than 200 days, but the 3 of us got a 200-day mission because of the vehicles blowing up, which was good. I didn't mind it. Plus, the benefit of flying as a NASA astronaut, you get per diem. Like when you go on travel, you get per diem every day. And NASA pays us $5 a day, and it's tax-free, so that was a good benefit. The Europeans and the Russians get more than that, but I won't say how much. This is a view of ATV-5, Georges Lemaitre. It was the last one ever, undocking. And I just think it's a cool video. It looks to me, I'll let you guys see what you think, and then I'll tell you what I think. This is backing away from the space station for the final time. And it was there for about 200 days when it left. This was Valentine's Day 2014. It looks like an X-Wing fighter leaving the Death Star is what I thought when I saw that. So about 2 or 3 hours after that, this is what we saw, and I was shocked. I went down there looking at it, and it fires its deorbit burn engines and comes back to the atmosphere and burns up. So this is the ATV-5 burning up in the atmosphere a few hours later. But it really surprised me because of how high up that was. It looks like it's above the atmosphere, but it just shows you that there is a very thin atmosphere, 100 or hundreds of kilometers up above the surface. One of the things, and I know many people in here have seen this, while I was in space, Leonard Nimoy passed away. He was Spock from the original Star Trek series. And it was the day before my 3rd spacewalk, and I was super busy, and I got an email, "Hey, Terry, Leonard Nimoy died. Can you do something?" And I didn't know what to do, so I was thinking, so I said, "I'll do the Live Long and Prosper." And I went down to the cupola, and I was trying to get the light. Lighting is always tough when you have inside and outside lighting, and I had a flash, and I was like, all right, I'll focus, and I'll get it done. I took the picture, and I tweeted it, and this was within minutes. It had tens of thousands of likes, and it got tens of millions of views. It was really popular. What I didn't know, and I found out later, can anybody recognize the background there? If you look on the right, there's a little hook. That's Cape Cod, Massachusetts. It's Boston. That's Leonard Nimoy's hometown. So I had no idea. I just was trying to get a picture. I had to go to a spacewalk. I just tweeted it. And I I got a picture of this over his hometown, which is really special. And it was a pretty cool cosmic coincidence, I thought. My favorite thing to do in space was take pictures. I took over 300,000 pictures. The poor NASA ground team was worn out by the photos that I was downlinking. It was the most ever that anybody's taken on a mission. But one of the reasons is we were filming this IMAX movie, Beautiful Planet, which is amazing. It's playing around the world. It's kind of a space mission in a movie. It's wonderful. But the module here is the cupola, and I got to install it on my space shuttle flight. So I brought the cupola up. So I kind of felt a personal connection to this module. It's every astronaut's favorite. If you ever hear an astronaut talk or whatever, this is their favorite place. There's 7 windows, and it's upside down. So the Earth, like to me, the Earth is there. That's just mentally, that's where I think of Earth is up. And you can see that in this picture. But it's kind of where I saw the universe from, and so it's really special. Lots and lots of views of Earth. This is one of the most powerful ones. It's a Hurricane Typhoon Mysak. I saw about 22 or 23 tropical cyclones in space. This one was amazing. It was massive. When I saw this, I said, hey guys, come on down here. And they all floated down, and everybody was gasping, grabbing cameras, taking pictures. There's a great view of this in the Beautiful Planet movie. But it was the biggest eye, I think, that had been seen in a long time. And I was talking to one of my Norwegian friends who was helping me, and I was telling her how big it was, and they said, oh, Denmark could fit in that. So that was funny. Another thing that you see in Norway, and I have never seen in my life, is the aurora. And the northern lights are very different than the southern lights. I just know them as the northern lights are in the distance, as this thin, beautiful green line. The southern aurora is really close to the station. In fact, there was one evening I flew through the aurora. It was the most surreal, beautiful experience. It was like a Star Trek movie, flying through this thing. And I didn't know it at the time, but everybody knows there's the geographic North Pole and the magnetic North Pole, and they're different. And actually it moves kilometers every year, many kilometers. But in the north, they're close to each other. In the south, they're farther away from each other. So the southern magnetic pole is closer to our orbit than the northern one is. And I knew this because I had seen it, but when I got back, I looked on Wikipedia and verified that that's true. So, but this is the northern lights. I want you to look at this, and you guys can see Trondheim here. This is one of my favorite pictures from space was a series of photos I took on this particular thing. There's High Trondheim in Oslo. In Denmark, you could see the size of the Mysak hurricane. There's St. Petersburg and Helsinki. And you'll see Moscow. Moscow is one of the brightest, most beautiful cities. It looks like a star at night. But this is, auroras never got old in space. This is a picture of where I'm from, the east coast of the US. And when I first flew on the space shuttle, I realized you can't really see humans during the daytime. If you know what you're looking for, you can see a city. Excuse me. But at nighttime, you can see city lights, and there's no doubt, right? There's people down there. In this picture, there's over 100 million people. It's Baltimore, Washington, Philadelphia, New York, Boston. You can see Chicago in the distance. This is a lot of population there on the East Coast. This is a tale of two cities. This is Paris and London in Western Europe. In the distance, you can see the Alps, and you could see Italy, and the boot is really obvious. But Paris and London are, from space, they're real close to each other. But I realized that I wasn't seeing population at nighttime, and I'd never thought of this until I'd flown in space. What I was seeing was wealth. And this is a picture from a very high altitude satellite. But between Cairo and the north, Cairo and the Nile are really bright and beautiful. You can tell everybody comes to the water. Everybody goes to the Nile. And in the south is Johannesburg. And Johannesburg looks like a European city from space. The light color, it looks like a European city. Between Cairo and Johannesburg, there's 1 billion people. And look how many lights are on down there. So the views that you see of city lights are not necessarily population, they're wealth. And that was something that really hit me when I flew in space. This view of the Koreas is the most striking view of humans on Earth. what we're looking at here on the right is South Korea. Seoul, South Korea is one of the brightest cities on Earth. It's the bright city there. And to the right, those are just South Korean cities. The little dots are fishing boats, so they're squid boats out fishing at nighttime. On the left, that's China. Beijing is kind of in the yellow Starmus sign, so Beijing is just off to the left. So there's South Korea and there's China. And the blackness in between the two, there's a brown river. See that brown river in the middle? That's the DMZ, the border between North and South Korea. And the blackness between Seoul and the Chinese cities is North Korea. So there's the same number of people living in darkness that are living in the light. And this white dot in the center of the picture is Pyongyang. And that's just really a striking example of how, unfortunately, some people live and others are able to live. But that picture to me really captured a lot about life on Earth in one shot. But beyond life on Earth, the Earth, and Samantha said this beautifully, the Earth is like a spaceship going through space, and we should think of ourselves as crewmates, not necessarily as passengers on the spaceship. But the view of the universe, at nighttime, you could go in the cupola when the Earth is when the space station is on the dark side of the Earth. You have to turn off all the lights. You have to cover up the computers. You have to turn off the lights in the Node 3 module, and really in the Node 1 module, turn off all the lights, make everything perfectly dark. And when you do that, you can see the universe that we're in. And there's a lot of stars out there. There's a lot of stars out there. You could probably see them from places in Norway when it's a clear night because there's no city lights. But up there's no city lights and there's no atmosphere. And it's amazing how many stars there are. I love astronomy and physics. As a kid, I used to get astronomy magazine. I'd wait every month to get my astronomy magazine. But I'm not an expert at it at all, but I know some of the constellations, and I kind of know my way around the sky a little bit. I literally could almost never find anything that I recognized other than maybe Jupiter stood out, Mars stood out. You could see Mercury. You never see Mercury from Earth. I saw it in space a lot. But other than that, I couldn't see anything because there's so many stars. So this is what it's like to be in space with the lights turned off. Another thing that I'd never noticed before was flying over the equator, this red band of really high altitude atomic oxygen. I didn't know what it was. I had to ask one of my physicist friends. That's atomic oxygen. But it shows up over Africa and really the equator. And before I flew in space, I never knew that there was differences in that. This is the galaxy. This is the galaxy that we're part of. But I love the stars and I love space, but man, Earth is like the one planet that we have, and it's a beautiful planet. So people ask what your favorite planet is, and some guys say Mars or Saturn or whatever. Earth's my favorite planet. There's a lot of good things here, so we got to take care of it. After 200 days, 199 and a half days in space, it was time to come back to Earth. I was out of chocolate. I had one piece of chocolate left, so I ate my last piece of chocolate. I wanted to take one more picture, so I went down to the cupola, and I set up the camera. I wanted to get a starburst, and I took there's some protective plastic on it, and so a lot of the pictures you see are beautiful, but they're smudgy. It's because of the scratch paint, so I took that off. Probably wasn't supposed to, but don't tell anybody. And I set up the camera, and I took this picture, and I looked at it on the back of the camera, and I said, that's the best picture I'm ever going to take in my life. I'm done. And I took the CF card out. I put it in the laptop to downlink it, and I went down to the Soyuz and put my spacesuit on and came back to Earth. And after these 200 days in space, plus the space flight, I was trying to think of what's the message, what's the takeaway for Starmus for this conference. And life on Earth is not always fun. It's not great. Everybody's a human being. Everybody makes mistakes. Everybody has problems. And the last couple of years, whenever something really bad or just some bad stuff has happened, I can close my eyes and I can kind of go back to space and think of a sunrise or sunset like this and think, there's been 1 billion of these sunsets before. There's going to be 1 billion more in the future. Somewhere on Earth right now, this is happening. If you were an astronaut lucky enough to be there, you could see this right now. So whatever's going on here in my life, whatever problems I'm having or whatever, I can kind of take myself back there and go, it's all going to be okay. Whatever, no matter how bad things seem, it's really not going to be that bad, and in the big picture. So I guess it's that perspective of, it's a big universe, things are going to be okay. They may seem terrible now. The sun will rise again tomorrow. If you're on the space station, the sun will rise again in 90 minutes. And I guess that's the message that I wanted to leave with you all. And I wanted to I'm a math guy. When I was a kid, I was a bad English student. I always felt, right now, I feel so badly for my English teachers because they had to suffer through having me in their class. But doing these amazing missions, I wanted to take my mission, and photography is kind of my thing, but also the stories of what it's like to be in space. So I kind of took those stories and photographs and put them together in a book. It's coming out in October, and hopefully that encapsulates what it's like to fly in space in both pictures and stories. Thank you very much for the Starmus conference. This is a great conference. We have a few more people. I'm going to add a few more minutes to your day. I have a really special guest right now, Catherine Gray, and when she was 10 years old, discovered a supernova. Thanks to her parents, they're very active parents, and they were helping her to go through data, and she sifted through data and discovered a supernova at the age of 10. She's from Nova Scotia and Canada, and I asked her, so this is kind of my thoughts on spaceflight and my mission, but I asked her to talk for a minute about what Starmus meant to her and how this week has impacted her. So Catherine, come on out. Let's give her a big hand. Awesome. Yeah. Stay right over here. And I'm going to say, Catherine opened up the very first Starmus. Was anybody there? I know some people were there. Yeah. And this is so awesome. This is Neil Armstrong with Catherine, as younger Catherine, there. So that's so cool. So Catherine.
Thank you.
Yes.
Hello. I suppose I'd like to start off by saying thank you to Garrick for inviting me back, and thank you to all of the other organizers and behind-the-scenes people that made this week possible. Thank you to all of the speakers that came this week and shared their knowledge with us. This is my second Starmus Festival. As mentioned before, I was at the first one. I did the official opening, and what an amazing week that was. I got to meet so many amazing people, and I learned so much. But this week has been even better. The people and the speakers that came this week were so amazing, and I've learned so much from them that I would have never learned anywhere else. I was here this week to do a small interview at the city program, and I was on stage with the interviewer, and out in the audience was a bunch of kids. And the interviewer was asking me questions like, why were you searching for supernovas? What did it feel like to find one? What are you doing now? And I think that's when I realized that this week, there's been an underlying theme of how important it is to inspire youth and encourage them to be curious and ask questions. And I can honestly say, as a youth here this week, I've been inspired by every single one of you. And that is something I will never forget. So thank you.
Thanks. Very good.
Thank you.
Just wait here. Yep. Catherine, I don't know what you're going to do when you grow up, but I kind of hope you stay in physics because I want to read about the discoveries that you make in the future. That's really cool. So everybody knows Garrick Israelian. He's the mastermind behind Starmus. He helped to organize this event. And as I said before, this week was amazing with the speakers that we had, the technical presentations. The entertainment is great. It's a wonderful combination of science and art. I especially love the VR program and the hands-on things that they had. But the thing I like most, Starmus is star and music, but I like festival because it really is a festival attitude. This is kind of an intimate conference, and I've spent hours talking. People just come up to me and ask me about it. I keep on running into all these famous people, and it's really cool to talk to them. And Starmus is a place that's, I think it's unique as a conference. You're able to interact with people, and that's what I've liked the most. But this one is much bigger than the past ones, and there was a lot of growth that happened, and I'm excited about that. I think it went really well. But let's welcome Garrick Israelian. He's the one that put this together. Garrick.
Thanks.
Thanks.
Thanks a lot.
Awesome conference.
Thank you.
Thank you so much.